So our next topic is atropine. It's very easy topic. Okay. So firstly, from where we get atropine? Biological source. Okay. It is a tropane alkaloid. So it comes under the category of tropane alkaloid. Okay. So it is a tropane alkaloid which is obtained from various species of Atropa belladonna, Datura stromanium, Datura metal, Datura inoxia, Hyoscyamus niger. All these things are the biological sources belonging to the family Solanaceae. Okay. So it is obtained, it is a tropane alkaloid which is obtained from Atropa belladonna or the Datura stromanium or the Datura metal, Datura inoxia or the Hyoscyamus niger belonging to the family Solanaceae. Okay, it also comes under the category of true alkaloids. We have studied under alkaloids, no, true alkaloids, false alkaloids and pseudo alkaloids. So it comes under true alkaloids. This is the structure of atropine. Okay, this is the exact structure of atropine. This actually usually looks like this. Here we get the NCH3. We have already drawn this diagram somewhere. Okay, anyways, so this is the structure. Next, production is also very easy topic. So firstly we will take the atropine, whether it might be the leaves or flowers, from whatever category you are taking. So for example, if you are taking the leaves, okay, so dried powder of the leaves has been collected and it is extracted with 95% alcohol. Firstly we have to extract it with 95% alcohol. Then when you extraction is been done, after that when you filter it, you collect the filtrate, not the mark. Okay, you collect the filtrate. The filtrate is collected and it is concentrated. సో యూ హ్యావ్ టు కాన్సన్ట్రేట్ అంటే ఏంటి, బాయిల్ చేసే కొలది దాని వాల్యూమ్ తగ్గిపోతుంది కదా, సో దాన్ని కాన్సన్ట్రేషన్ అంటాం. ఓకే, సో కాన్సన్ట్రేటెడ్ ట్రీట్ విత్ డైల్యూట్ హెచ్సిఎల్. ఆ కాన్సన్ట్రేటెడ్ మాస్ ఏదైతే మిగులుతుందో, విచ్ వన్ ఈజ్ లెఫ్ట్, ఓకే, దట్ కాన్సన్ట్రేటెడ్ మాస్ ఈజ్ ట్రీటెడ్ విత్ డైల్యూట్ హెచ్సిఎల్. యూ ఆర్ ట్రీటింగ్ ఇట్ విత్ డైల్యూట్ యాసిడ్, ఓకే, డైల్యూట్ హెచ్సిఎల్, అండ్ దెన్ యూ ఫిల్టర్ ఇట్. ఓకే, next the filtrate is been collected, same as above, the filtrate is collected. So firstly alcohol add చేసినప్పుడు we have collected the filtrate, we have concentrated it, we have added the dilute HCl, and again you have filtered it, you have collected the filtrate. Okay, and then now you will add ether, petroleum ether. Okay, so then what happens, you will get two layers, partitioning is been done. Okay, so when you add petroleum ether, you will get a petroleum ether layer and as well as a acid layer. Two layers have been formed. So you will take the acid fraction, the one which is above or below, which is made up of acid, that fraction you will take. The acid fraction is made alkaline with adding ammonia. It is acid, no, so that's why you have to add the base, that is ammonia is added. Okay, now you will get a precipitate of alkaloids which are in the form of salts. Okay, precipitate of alkaloids are been obtained. Now extract or partition with chloroform 3 times. So 3 times 10 ml, 10 ml, 10 ml. In that way you have to add chloroform for 3 times, and you have to you will get 2 partition layers. That partition layer you have to collect. Okay, chloroform layer, what is the chloroform layer partition, that you have to collect 3 times. All the 3 times you will collect the chloroform layer and you will pull up all the collected chloroform layers, combine all the chloroform layers, remove the chloroform. So when you concentrate it or when you produce the heat, the chloroform gets evaporated and you will get a residue. Okay, that residue, when you add oxalic acid solution, the alkaloids which are present inside it gets crystallized out, crystals are been obtained, and for that again for purification process you go for recrystallization, and finally you will get a pure form of atropine crystals. Okay, very easy. Firstly you will take the powdered drug, you will add the alcohol extraction, you will do, okay, 95% alcohol, that might be ethanol or methanol, you will add that, you will collect the filtrate, you will concentrate it, and to that you will add the dilute HCl, you will add the acid. Okay, you will add the acid, again you filter it, you will collect the filtrate, and to that you add the petroleum ether, so that you will get 2 partitions, but you need to collect the acid layer. So after the 2 layers are been produced, you will collect the acid layer. As it is acid in nature, you will add ammonia, strong base. Okay, to make it alkaline. So then you will again then what will happen when you add the base, the alkaloids gets precipitated out. So that then to remove that precipitated alkaloids, you'll add chloroform 3 times, okay, and you'll get 2 layers. From that you will collect all the chloroform layers and you will combine them. Again you remove the chloroform and you will get the residue. To that residue we need the alkaloids in crystal forms. For that you will add oxalic acid solution, so that all your alkaloids get crystallized out and you again recrystallize it to get the pure form of alkaloids. That is how atropine alkaloids are been obtained. Okay, atropine gets crystallized out. Next, uses. So it acts as a parasympathetic drug with anticholinergic properties. Okay, that is the first important importance. Next, second one, it used in surgeries as anti-silagogues. Anti-silagogue means which decreases the secretions like gastric secretions or saliva. So during the surgical processes, this saliva or gastric juices secretion has to be reduced. So for that reason, before anesthesia, okay, before anesthesia, these are given as IM, intramuscular injections, so that the saliva or gastric juices or whatever juices which are being secreted out, that can be reduced. Next, it acts as an antidote for poisoning conditions in the case of organophosphate poisoning or carbamate insecticide poisoning or opium poisoning or chlorohydrate poisoning. In all those cases, it acts as an antidote. Next, it also acts in the case of bradycardia for reducing the heart rate. Okay, bradycardia. Next, it acts as an antispasmodic drug. Antispasmodic means muscle contractions can be released, relaxation can be obtained. Spasm means constrictions. Okay, so during that muscle constrictions, in that case when you give these injections, it relaxes those muscles. Next, also acts as a mydriatics. Mydriatics means increases the pupil size. So during the ophthalmic surgeries, we need to the middle portion, that hollow space will be there, no pupil, that space has to be dilated, so that the insertions or whatever surgery has to be done can be easily done. So for in that case, it acts to increase the pupil size. Okay, that is about the uses. Finally, the identification test. So the main test which is vitally Morin test, which is mainly for tropane alkaloids. So as atropine is a tropane alkaloid, we have to go for vitally Morin test. So sample is taken, to that concentrated nitric acid is added. When we evaporate on the water bath, you will get a thin layer. That layer is pale yellow residue. Okay, pale yellow residue. When this pale yellow residue is added to acetone, okay, when you mix up with acetone and few drops of alcoholic KOH is when added, you get violet red color. Okay, you will get violet red color. Next, TLC method. You will take the stationary phase silica gel G, melting mobile phase acetone is to 0.5 molar NaCl. Detecting agent is Dragon-Roth reagent. So finally what you will do, you will keep the test sample and you will keep the standard. When you observe the spots, okay, you will get yellow orange spots. You will get yellow orange spots with a RF value of 0.70. That is about the TLC. And another test is assay of atropine. Sample plus 5 ml of alcohol is taken. You mix the sample with alcohol and methyl red already. This whole thing has to be done. Next, now take HCl and titrate. So in the pipette you will take the HCl. Okay, HCl and titrate. Excess of this acid with 0.1 normal sodium hydroxide using methyl red as indicator. Now 0.1 normal HCl is equivalent to 0.02894 grams of atropine. This you know how to do the assay process, right? So this is how you do. So this is the very easy topic, that is about the utilization, estimation and biological source of atropine.